A man flies a small airplane from Fargo to Bismarck, North Dakota, a distance of 180 miles. Because he is flying into headwind, the trip takes him 2 hours. On the way back, the wind is still blowing at the same speed, so the trip takes only 1 hour and 12 minutes. What is his speed in still air, and how fast is the wind blowing? Make sure you read the question carefully a couple times to understand the context, the scenario. The better we understand the context of the problem, the more comfortable we are with solving it. To better understand the problem, we might need to draw a diagram, use suggestive letters to summarize the English phrases, and translate them into mathematical expressions. The first sentence, the man flies a small airplane from Fargo to Bismarck, a distance of 180 miles. So we have two locations, Fargo to Bismarck, with a distance of 180 miles, and we assume that this is a horizontal distance. This distance is 180 miles. Because he is flying into headwind, the trip takes him 2 hours, so the wind is slowing him down. He flies into headwind. On the way back, the wind is still blowing at the same speed, so the trip takes him 1 hour and 12 minutes only. It takes him shorter time to cover the same distance because this time he is flying with the wind as opposed to against the wind in the trip from Fargo to Bismarck. We're looking for the speed of the airplane in still air and the speed, how fast is the speed of the wind. Usually, the last sentence will ask us to find certain quantities. In most cases, we will let the quantity be a variable. We use generic variable x and y, but sometimes we use suggestive letters as well. In this case, we will let x be the speed of the airplane in still air. This needs to be specific. X is not the airplane. X is not still air, but x is the speed. It is better also to include the units. The speed is miles per hour, so the answer will be a number miles per hour. We then let y be the speed, how fast is the speed of the wind, how fast the wind is blowing, y is the speed that the wind is blowing. In all of these type of question or problems, we would need to come up with a system of equation if we have two or more unknowns. If there are two unknowns, we need to come up with two equations using the given information. We're given the information about the distance, the speed, even though the speeds are not known, and the time. The relationship between the speed, the distance, and the time is that the distance is the speed times the time, or the speed is the distance divided by the time, or the time is the distance divided by the speed. Depending on the given information, sometimes we use one of these three, although it doesn't matter which one because they are all equivalent. If we use the first relationship, the distance equals the speed times the time, we would have 180 equals the speed times the time. We then find two equations using this relationship, one going to and the other one going back. S in this relationship has to be the actual speed. This is not just the speed of the plane or the speed of the wind. If we go against the wind, then the actual speed will be less, and if we go with the wind, then the actual speed will be more. Think of it as if we fly into headwind, then our speed will be slower, and if we fly with the wind, then the speed will be more, or we're going faster. It is the same concept as if we were to bike a bicycle. If we bike into headwind, then we would go at a slower speed. The actual speed is therefore, if we go against the wind or flying into headwind, the actual speed will be the speed of the airplane, which is x, minus the speed of the wind, which is y in this case. If we're flying with the wind, then the speed will be the speed of the airplane, and the wind is pushing the airplane to go faster. The distance is the same going to or back, and so d is fixed 180. The time going to is 2 hours, and going back it is 1 hour and 12 minutes. We need to convert it into hours. 1 hour and 12 minutes is 1.2 hours, because 12 divided by 60 is 0.2. 12 minutes is 0.2 hours. So the first equation, going to, is the distance equals 180. 180 equals the speed is x minus y times the times 2. Going back, the distance is still 180, but the speed is now x plus y times the time, which is 1.2. We then obtain a system of equation. 2x minus 2y equals 180. 1.2x plus 1.2y equals 180. We can now forget about the word problem and focus on solving this system of equation using either elimination or substitution method. Before we decide which method to use, observe that we can obtain a simpler system of equation. We divide by 2 from both sides of the first equation to obtain x minus y equals 90. We divide by 1.2 from both sides of the second equation to obtain x plus y equals 150. 180 divided by 1.2 is 150. It is preferred that we simplify the system of equation before we try to solve it. It is okay to multiply or divide a non-zero from both sides of the equation. Now that we have negative y in the first equation and positive y in the second equation, we can add the two equations to obtain 2x equals 240, so that x equals 240 divided by 2, or 120. The unit is miles per hour. Once we obtain x, we can perform a back substitution to find y, and it doesn't matter which equation we use. If we use the second equation, then x is 120 plus y equals 150, so that y equals 150 minus 120, which is 30. This is also mile per hour. And so we found that x equals 120 miles per hour and y equals 30 miles per hour. We can check to see if the solution satisfies the system of equations. The answer for the word problem has to be a description. What is x and what is y? The good thing we were specific about x and y earlier. We let x be the speed of the airplanes, so that we now state the speed of the airplane is 120 miles per hour, and the wind is blowing at a speed of 30 miles per hour. So we answer both of the questions in the problem. Let's double check our work. To fly from Fargo to Bismarck, the speed of the airplane is 120 and the speed of the wind is 30. The wind slows down the airplane. So the actual speed is 90. 90 times 2 hours is 180. So the answer checks out.